Imagine this for a moment. Right now, as you're listening to this, light is racing through the universe at nearly 300,000 kilometers every single second. A beam of light could circle the Earth more than 7 times in just 1 second. It's so fast that for over 100 years, physicists have treated it as an unbreakable law of reality. The ultimate speed limit. The final answer. Nothing can go faster than light. That's what we're told. That's what's written in textbooks. That's what Einstein himself seemed to prove. But here's the uncomfortable question almost no one asks out loud. If the speed of light is truly the fastest thing in the universe, then why does reality keep behaving like it isn't? Think about this carefully, not emotionally, logically, because the moment you do, cracks begin to appear. Tiny at first, easy to ignore, but once you see them, they don't go away. Let me ask you something. Have you ever noticed how gravity seems to know where objects are instantly? When the sun exists, Earth feels its pull. When stars collapse into black holes, galaxies react. But according to the rules we're taught, gravity shouldn't act faster than light. Information shouldn't travel faster than light. And yet, the universe behaves as if something already has. And that's just the beginning. Because what if I told you that there are things in physics that don't move faster than light, but still outrun it anyway? What if the speed of light isn't the fastest thing at all, but just the fastest thing we can see? Stay with me, don't blink, because once you understand this, you'll never hear "nothing is faster than light" the same way again. For most of human history, speed meant nothing more than how fast something moved across space. A horse, an arrow, a cannonball. Then came electricity, then radio waves, and finally, light itself. When scientists measured its speed, they were stunned. Light wasn't just fast, it was absurdly fast. Faster than anything they could imagine outrunning it. And then Einstein did something that changed everything. He didn't just say light was fast, he said it was special. He said the speed of light wasn't just another number, it was woven into the structure of reality itself. Space and time bend to protect it. Clocks slow down. Lengths shrink. Mass increases. Also that no matter how fast you move, light always wins. It sounds unbeatable, perfect, final. So why are physicists still uneasy? Because Einstein's rules came with consequences that no one fully understood at first. Consequences that only reveal themselves when you push reality to its limits. Here's one of them. If nothing can move faster than light, then no cause can influence and affect faster than light either. No signal, no force, no information. Reality should unfold step by step, limited by that cosmic speed limit. But quantum physics didn't get the memo. In the quantum world, particles don't behave like objects. They behave like possibilities. And sometimes those possibilities appear to communicate instantly, no matter how far apart they are. This phenomenon is called quantum entanglement. 2 particles become linked. Measure one, and the other responds instantly. Not after a delay. Not after light has time to travel between them. Instantly. Einstein hated this. He called it spooky action at a distance. And here's the terrifying part. Experiments have proven it's real. Over and over again. Across increasing distances. Across cities. Across continents. So let me ask you directly, if nothing is faster than light, how do 2 particles separated by kilometers behave as if distance doesn't exist? Physicists will tell you, no information is transferred. But then pause. Ask yourself honestly, if the universe responds instantly, what is doing the responding? Because something is, and it doesn't care about the speed of light. Now let's zoom out, way out. Back to the birth of the universe itself. The Big Bang. According to everything we know, the early universe expanded at a rate that seems impossible. Regions of space that should never have been able to communicate, because light didn't have time to travel between them, somehow ended up perfectly synchronized. Same temperature, same structure, same laws. This problem is called the horizon problem. And to fix it, physicists had to introduce something extraordinary. Inflation, a period where space itself expanded faster than the speed of light. Not objects moving through space, space itself stretching. And here's where the rules start bending. Because Einstein's speed limit only applies to things moving within space. It doesn't apply to space itself. And when space stretches, distances can increase faster than light can cross them. So let me ask you something unsettling. If space can outrun light, then is light really the fastest thing? Or just the fastest thing trapped inside space? This distinction matters more than you might think. Because once you accept that space itself isn't bound by light speed, other uncomfortable possibilities follow. Possibilities physicists rarely discuss outside academic papers. For example, what about the expansion of the universe right now? Distant galaxies are moving away from us faster than the speed of light. Not because they're breaking the rules, but because the space between us is expanding. Light from them will never reach us. Ever. They're already gone from our observable universe. Erased. Forever unreachable. Ask yourself this. If light can't catch up, what does that say about what truly governs motion at the largest scales? And then there's gravity. Gravity isn't just a force. According to Einstein, it's the curvature of spacetime itself. Massive objects don't pull on each other. They bend the fabric of reality, and everything else follows the curves. But here's the problem. When a massive object moves, how fast does spacetime update? If the sun vanished right now, hypothetically, would Earth continue orbiting for 8 minutes, waiting for gravity to arrive at light speed? Or would something deeper update instantly? Physicists say gravity travels at the speed of light, but experiments struggle to measure it cleanly. And mathematically, spacetime behaves suspiciously like something that already knows where mass is everywhere all at once. This is where things start getting dangerous. Because now we're no longer asking whether something moves faster than light. We're asking whether motion itself is the wrong question. What if the fastest things in the universe don't move at all? What if they don't travel through space? But define space. Think about information. Information doesn't always need a carrier. Sometimes the structure itself contains it, like a rule embedded into reality. In computer simulations, characters don't need messages to obey gravity. Gravity is part of the code. Instant, universal, everywhere. Now imagine, just for a second, what if our universe has something similar? A deeper layer, a hidden framework, a set of rules that update reality everywhere at once. Not traveling faster than light, not breaking Einstein, but bypassing the need for motion entirely. This idea sounds radical, but it keeps showing up. In quantum mechanics, in cosmology, in theories of spacetime, again and again. And every time it appears, it whispers the same unsettling suggestion. Light isn't the fastest thing. It's just the fastest messenger inside a system that runs on something deeper. Let me ask you something personal. When you think, does the thought move from one neuron to another like a particle traveling through space? Or does awareness emerge all at once across your mind? Physics might be facing a similar mystery. And here's where part 1 ends on purpose. Because the next step is where things get truly uncomfortable. In part 2, we're going to explore the things that don't move faster than light, but still outrun it. The things that make physicists argue late into the night. The theories that suggest reality updates like a frame-by-frame simulation. And the terrifying possibility that the speed of light isn't a limit, but a bottleneck. So before we continue, I want you to pause and think. If something exists that doesn't need to travel, if something can influence reality without crossing distance, would you even recognize it as speed? Or would it already be shaping everything you see? Stay with me, because what comes next challenges everything you think you know about how the universe actually works. Before we go any further, let me ask you something quietly. When was the last time you questioned what speed actually means? Not how fast a car moves or how quickly data loads on your phone, but speed at the deepest level of reality. Because part 1 planted a dangerous idea in your mind. That maybe light is not the fastest thing in the universe, but only the fastest thing we notice. Now part 2 is where that idea stops being philosophical and starts becoming disturbing. Imagine you are watching a movie. On the screen, characters run, explosions happen, galaxies form and collapse. Inside the movie, everything appears to move through space and time, but behind the screen something very different is happening. The entire universe of that movie updates frame by frame instantly, every pixel at once. Nothing inside the movie moves faster than anything else because the real action is not movement, it is updates. Now here is the uncomfortable question. What if our universe behaves more like that movie than we want to admit? Because when physicists look closely, speed starts behaving strangely. Let us go back to quantum entanglement without the safe explanations. Two particles are created together sharing a single quantum state, then separated sometimes light years apart. When one particle is measured, the other responds instantly with no delay and no signal traveling between them. If this happened anywhere else, we would call it faster than light communication, but because it breaks theory, we rename it. They say no information is transmitted, yet something correlates, something updates, something changes everywhere at once. This is not fringe science, it is one of the most tested phenomena in physics. So ask yourself, if entangled particles do not communicate through space, where does their connection exist? Because it clearly does not care about distance. This leads to a disturbing realization that distance might not be fundamental. Space itself may emerge from something deeper. And if space is not fundamental, then the speed of light is not fundamental either. It is simply the fastest speed allowed inside space. Now consider black holes. According to quantum mechanics, information cannot be destroyed, yet black holes seem to erase everything that falls in. To resolve this, physicists discovered that information behaves as if it is stored on the surface, not the volume, leading to the holographic principle. Our three-dimensional universe may be a projection governed by deeper rules. In a hologram, information does not travel point to point, it updates as part of a single structure. If that is true, then light speed limits apply only to the projection, not the underlying reality. This becomes even stranger at the smallest scales, where space and time become grainy and discrete like resolution limits. Physics keeps using words like frames, updates information, and encoding. Once you see this, the speed of light looks less like a universal limit and more like a bandwidth limit. The fastest rate information can propagate inside the system, not the rate at which the system itself updates. Think about gravity. When black holes collide, gravitational waves arrive at light speed, but spacetime itself behaves as a single consistent geometry, as if it already knows how to curve. Rules do not travel, they apply everywhere instantly. And then there is time. Time slows near massive objects, slows at high speeds, and can stop entirely at black hole horizons. There is no universal now. So what does faster even mean, and according to whose clock? Some interpretations of quantum mechanics even suggest future measurements can influence past states. Retrocausality. Experiments keep hinting at this, which makes the speed of light look like a guideline for surface reality, not the deeper layer beneath. What if the universe does not compute the future step by step, but solves everything at once as a self-consistent structure? In such a universe, nothing needs to move faster than light, because nothing needs to move at all. During inflation, space itself expanded faster than light, yet the universe remained uniform because everything was once already connected. Distance came later as a consequence, not a cause. This leads to the radical idea that spacetime itself emerges from entanglement, and without those connections, space would fall apart. So if space is built from relationships that ignore distance, what does faster than light even mean? Maybe the fastest things in the universe are not particles but correlations, rules, and constraints. Light is simply the fastest thing allowed to move inside that architecture. And that brings us to the edge, because everything so far barely fits known physics. But what comes next goes beyond it, and that is where everything truly comes together. Before we finish this journey, let me ask you something deeply personal. If everything you've ever experienced, every second, every motion, every moment of time, is shaped by rules you can't see, would you still call the universe simple? Because part 3 is where all the pieces lock together. And once they do, the speed of light will never feel like the ultimate limit again. Up to now, we've talked about things that appear faster than light. Entanglement, inflation, spacetime itself. But now we have to face a more unsettling possibility. What if the fastest things in the universe don't have speed at all? What if speed is only a feature of the surface reality, the part we can observe, while the deeper layers operate without motion, without delay, without time as we understand it? To understand this, we need to abandon our everyday intuition. Because intuition was built for survival, not for cosmic truth. Let's start with dimensions. You live in 3 dimensions of space and 1 of time. Movement makes sense to you because space exists. Time flows because your brain experiences it that way. But physics allows for more dimensions. Not science fiction dimensions, mathematical ones that appear naturally in the equations. In some theories, these extra dimensions don't have distance in the way we understand it. 2 points can be adjacent without being near. Cause and effect don't require travel. Now imagine a reality like that. No speed. No delay. Just relationships. If our universe is embedded in something like this, then what we perceive as motion might simply be a shadow of deeper interactions playing out beyond space and time. And suddenly, the speed of light looks less like the fastest thing, and more like the fastest shadow. Now let's talk about something even more unsettling. The universe doesn't just evolve, it obeys constraints. Physical laws aren't suggestions. They're conditions that reality must satisfy everywhere, all at once. Conservation of energy, charge symmetry, quantum probabilities. These laws don't travel through space enforcing themselves. They are simply true, everywhere, instantly, and that should bother you, because it means the universe doesn't need signals to maintain consistency. It doesn't wait, it doesn't check, it just is. This leads to a radical but growing idea in physics, that the universe is not fundamentally causal in the way we think. That instead of events causing other events through time, reality is constrained globally, like a completed puzzle where every piece already fits. From this perspective, the universe isn't happening. It's already solved. Time isn't something flowing forward. It's something we experience locally as we move through a fixed structure. Now pause, because if this is true, then the speed of light isn't the fastest thing in the universe. It's simply the maximum rate at which change can propagate within our slice of that structure. But the structure itself doesn't propagate. It exists. This brings us to one of the strangest and most controversial ideas in modern science, that the universe updates in discrete steps, tiny moments where reality recalculates itself. Between these moments, nothing happens. No motion, no time, just potential. If this sounds familiar, it's because it resembles computation. Again, not proof, but a pattern. And if the universe does update itself, then light is just the fastest thing allowed to move during an update, not between them, which means something deeper, something timeless, is doing the updating. Now let's connect this to consciousness, because this is where the conversation becomes unavoidable. Your thoughts don't feel like particles traveling through space. They feel immediate, unified, whole. You don't perceive your awareness arriving neuron by neuron. You perceive it as a single experience. Some physicists and philosophers believe this is not a coincidence. They suspect consciousness may be tapping into the same deeper layer of reality, the one that doesn't rely on speed, the one where information is integrated, not transmitted. And if that's true, then the fastest thing in the universe might not be light. It might be awareness, or more precisely, the structure that allows awareness to exist at all. Now let's bring this back to physics. Why does the universe have a speed limit in the first place? Why not infinite speed? Why not instant communication everywhere? The answer might be stability. A universe where everything updates instantly at all levels would be chaotic. No locality, no structure, no causality. The speed of light may exist not because it's the fastest possible thing, but because it's the fastest safe thing. A regulator, a limiter, a way for complex structures like stars, planets, and minds to exist without collapsing into noise. From this view, light isn't the champion. It's the compromise. And now we arrive at the final realization. The question, what's faster than light, might be the wrong question. The real question is, what doesn't need to be fast at all? Because the deepest mechanisms of reality may not race through space. They may not move. They may not even exist in time. They may simply define the rules that everything else follows. Silently, everywhere, all at once. So the next time someone tells you that nothing is faster than the speed of light, remember this. Light is the fastest thing inside the universe. But the universe itself may be governed by something that doesn't move, and therefore doesn't need speed. And if that's true, then we're not living in a reality limited by light. We're living in a reality built on something far deeper, something that lets light exist in the first place. If this changed the way you think about the universe even a little, then this is exactly the kind of question we explore on Lurix. So take a moment, subscribe to Lurix, because we don't just explain science here, we question its boundaries. And if you stayed until the end, I want you to answer this in the comments. If the speed of light isn't the ultimate limit, what do you think really is? Because the most important discoveries don't start with answers. They start with the right questions. And this was one of them.